In this lecture, we will compare BJT and JFET. We have already compared the field effect transistors, with the bipolar junction transistors in the introduction lecture, and that part will remain same in this lecture also. You can see two columns on your screen. The first column is for BJT, and the second column is for JFET, the junction field effect transistor. I will write down all the important points related to BJT in the first column and all the important points related to JFET in the second column. In the first point, we will see the symbol of the two devices. The two devices are 3-terminal devices, and the 3 terminals in case of BJT are base terminal, collector terminal, and the emitter terminal. And in case of JFET, the 3 terminals are gate terminal, drain terminal, and the source terminal. In case of BJT, we have two types. The first one is NPN, the second one is PNP. In case of JFET, we again have two types. The first one is N-channel JFET and the second one is P-channel JFET. And to differentiate between NPN and PNP, we will take help of the emitter current IE. In case of NPN transistor, the direction of emitter current is like this, and in case of PNP transistor, the direction of emitter current is like this. So if we are taking NPN transistor, we will put a small arrow representing the direction of emitter current IE. In the same way, we will take help of gate current IG in case of JFET. For N channel, the direction of gate current is like this, and for P channel, it is like this. And if we are considering it as N channel JFET, I will put the arrow like this. And remember one thing, in case of analog electronics, if you see any direction in the circuit, then that direction is for the current. It is not for the flow of electrons, but for the conventional flow of current. In these two cases also, the arrow is representing the direction of two conventional currents. In case of BJT, the current is the emitter current, and in case of JFET, the current is the gate current. Now we will move to the input and output parameters. In case of BJT, the input current is the base current represented by IB, and the output current is the collector current. The input voltage is VBE, and the output voltage is VCE. In case of JFET, the input current is IG, the output current is the drain current ID, and current in this branch is the source current. The input voltage is VGS. The output current IC is the function of input current IB. We already know this point. The output current IC is the function of input current IB, or we can write IC is equal to beta times IB. In case of JFET, the output current ID is not the function of input current IG, but the function of input voltage VGS. The drain current, the output current, is function of input voltage VGS, or we can write ID is equal to IDSS, the maximum drain current, inside the bracket 1 minus VGS divided by VP, where VP is the pinch of voltage whole square. So in case of BJT, you can see IC is dependent on the base current IB. So the control variable is the base current. On the other hand, in case of JFET, the output current ID is dependent on voltage VGS, because IDSS and VP are constant. IDSS and VP are constant. So VGS is the control variable, and because of this reason we call BJT current control device, because the output current is controlled by the input current. We will call it current controlled device. On the other hand, we will call JFET voltage controlled device. Very simple. The fourth point is related to the charge carriers. In case of BJT, the both charge carriers are involved, both electrons and holes are involved, and because of this reason we call BJT bipolar device. In case of JFET, only one type of charge carrier is involved, either electron or holes, so we will call JFET unipolar device. Unipolar device. When electrons are the only charge carriers, we call the JFET N-channel JFET, and when the charge carriers are holes, we call it P-channel JFET. The collector current is nearly same as the ammeter current. The collector current IC is nearly same as the ammeter current IE, and in case of JFET, the drain current ID is same as the source current IS. The drain current ID is equal to the source current IS. Now we will move to the sixth point. The input voltage VBE is equal to 0.7 volts. VBE is equal to 0.7 volts for silicon transistor, and in case of JFET, the gate current is equal to 0 amps, and you have to tell me why the gate current is equal to 0 amps. This is the homework problem. Try to explain the reason in the comment section. In the seventh point, we will talk about fan out. In case of BJT, the fan out is good, and in case of JFET, the fan out is bad. The fan out is bad. Now what do we mean by fan out? Fan out will tell us maximum number of devices BJT or JFET can power. Now let's move to the eighth point. You can see the relation between current IC and IB. It is linear. So we will call BJT linear amplifier. And in case of JFET, the relation between current ID and voltage VGS is non-linear. Because of this square, the relation is non-linear. So we will call JFET non-linear amplifier. Non-linear amplifier. The power consumption in case of BJT is more. The power consumption is high as compared to the power consumption in case of JFET. And if we talk about input impedance Zi, then input impedance is lower as compared to the input impedance in case of JFET. The input impedance of BJT is lower than the input impedance of junction field effect transistor. The next point is the thermal stability. BJT has bad thermal stability. JFET has good thermal stability as compared to BJT. JFET has good thermal stability. If we talk about gain, then gain of bipolar junction transistor is high and the gain of JFET is low. The sensitivity of BJT is less. The sensitivity of BJT is low as compared to the sensitivity of JFET. Now we will move to the 14th point. The noise level of BJT is high. The noise level of BJT is high as compared to the noise level of JFET. And the last point is the size. the size of BJT is larger as compared to the size of junction field effect transistor, and because of this reason it is good to use JFET in the integrated circuits. We use field effect transistors in the integrated circuits instead of using the bipolar junction transistor. So this is all for this lecture. We discussed 15 points, and if you have any doubt you may ask in the comment section. There is one homework problem also in this lecture. You need to tell me why the gate current Ig is equal to 0 amps. So this is all. See you in the next one.